This question says, find the equation of the function from the graph using the form f of x equals a times b to the power of x. So this form right here, this represents an exponential function. So this graph is an exponential function. We're just trying to figure out what is the equation of the function. So it helps to understand that when we have a graph in this form, f of x equals a times b to the power of x, when b is greater than 1, our graph represents exponential growth, which looks something like this, where as the x values get larger, the y values also get larger. But if b is less than 1, then we have something known as exponential decay. And that's when, as the x values get larger, the y values actually get smaller. But what we'll notice in both of these graphs is that the horizontal asymptote, or the y value that both graphs are approaching, is just 0. So they're both approaching a y value of 0, but they're never quite touching 0. Now what we'll notice on our graph over here on the left is that it appears that the horizontal asymptote is actually located at y is negative 4. So what that means is that when we write our function f of x is equal to a times b to the power of x, we're actually going to subtract a 4 at the end, because it looks like this whole graph is shifted down 4, since the new horizontal asymptote is at negative 4. So this is the general form that we're going to write our equation in. All we need to know is what are the values of a and b. So to find a and b, here's what we can do. We can first identify the y-intercept. So where does the graph cross the y-axis? That would be right here at the point 0, negative 2. So let's write that. And then we just need to identify one more point on the graph. So here we have negative 1, positive 2. The graph also crosses this point, so let's write that. Now what we'll be able to do is plug in these x and y coordinates into this equation, and we'll be able to solve for a and b. So I'm going to clear a little space right here. Okay, so first we're going to plug in the values of the y-intercept into this equation. So we're going to plug in a 0 for x and a negative 2 for y, and we'll be able to solve for a. So here's what we get. Negative 2 is equal to a times b to the power of 0, so we're plugging in a 0 for x, and then minus 4. Now, what we'll find is that anything to the power of 0 is just 1. So really, this is just 1. So what we have is negative 2 is equal to a times 1, or just a, minus 4. To solve for a, we can add a 4 to each side, and we'll find that 2 is equal to a. So a is equal to 2. Now what we can do is plug in the values of this other point that we identified, negative 1, 2. We'll plug it into this equation and we'll solve for b. So let's see what we get. So I'll clear a little space here again. Okay, so we'll plug in a 2 for y. So we get 2 is equal to a. We just figured out that a was equal to 2. So we'll have 2 times b to the power of x. So for x, we're going to plug in a negative 1 right here. And then we have minus 4. So we're trying to solve for b, so we could add a 4 to each side to start with. So 2 plus 4 is 6, so we get 6 is equal to 2 times b to the negative 1. We could then divide both sides by 2. So 6 divided by 2 is 3, so we get 3 is equal to b to the negative 1. Now, b to the negative 1, that's the same as 1 over a positive b. So if we want, we can write this as 3 over 1 is equal to 1 over b. And now to solve for b, we can just cross multiply. So we get 3 times b is equal to 1 times 1. So 3b is equal to 1. And then to solve for b, we can divide both sides by 3. And we'll find that b is equal to 1/3. So we found that a was equal to 2 and b was equal to 1/3. So our final answer is just going to be, I'll clear a little space right here. Y is equal to 2 times 1/3 to the power of x minus 4. This is the equation that this graph represents. Or if you wanted to, you could also replace y with an f of x. Either form is fine. And since we ended up getting a b value, so this value right here of less than 1, that means the graph should have exponential decay, which it does. As the x values get larger, as we're going more and more to the right, the y values are decreasing. So that's just a way to kind of double check or confirm that we got the right pattern.